So good afternoon. Myself Vinayakamurthy from Midas IT. So today I will explain about the basic steps for the modeling, and I will make one model for the beginners, as well as I will first of all I will just get start my training up with the graphic user interface and modeling concept and loadings and analysis part. So these are the general steps for any type of structure modeling, and we will be planning for the two sessions for you. The one is for the basic modeling and loading concept over there, and the second session I will be covering the construction stage analysis and the segmental bridges. This is my steps for the training program. So first of all, I will just open the software and explain about the graphic user interface. So this is the software page which you are seeing here, and this is the top icons. This is the file, the icon symbol which is showing for the Midas civil, that is for the file also. Here you can see the new project, open project, and import the file. This program is giving the facility to import the file from other interface like MCT file. Midas MCT file is the Midas command text editor file. It is similar to STAD editor. And this AutoCAD geometry. You can import the geometry from AutoCAD file, and you can import the model from SAPS, STAD, MS Nastran, and LUSAS. As well as you can use the export command. You can export to other interface like a text editor file and MXT file for Midas FEA and GTS. And again, you can export the model to AutoCAD DXF, frame section for solids, plates, and IFC files. And this top menu system, which is explaining you, the first one is a view. These are the dynamic view functionalities. And second tab is a render view. Next is selection. So this selection icon, we have several types. Select by single window polygon. The same icon we'll use for the selection of nodes and elements. Next is the activities, active, inactive, and all. So this things will be activity means in a geometry we can select the particular portion and click active, then select portion will be visible in the screen, remaining portion will be hidden. And the second is inactive, only the selected portion will be hidden in the screen, the remaining portion will be appear in the screen. And active all, it will show the entire geometry in the screen. And the UCS, and the UCS axis is X is longitudinal, Y is transverse, Z is vertical. It is similar to your AutoCAD GUI. And this display function, you can control the displays like a node number, element number, element local axis, properties, boundaries, loads, everything. And display option, this will control your background colors and font size and everything. Again, next is a structure. The first one is a structure type. So by the structure type, the program will analyze the structure as a 3D by default, or if you want to analyze the structure in 2D, then we have to select which plane you want to analyze it, XZ, YZ, XY, or constant or Z axis, and the Morse control parameters for the dynamic analysis, and gravity acceleration and initial temperature for thermal analysis. And the second location is, this is the wizard. The wizard is nothing but the ready-made template to make your model very quickly. So we have the wizards for the basic structure like a beam, column, arch, frame, truss, plate, shell elements. Apart from that, we have the wizard for suspension bridges, cable stayed bridges, ILM incremental launching method, FCM free cantilever method, MSS mobile scaffolding system, FSM full staging method, and transverse model, grillage model, RC slab bridge, RC frame, and box culverts. And along with that, we have the steel composite and prestressed composite bridges. And then here the UCS, this UCS control which comes under the structure, which we can change the UCS as per our convenience, because generally this will be useful for whenever you are making a structure in curved and profile. And next is a group, the structure group, boundary group, load group. So these are the group we are creating for mainly for the construction stage analysis purpose. So these groups we are just activating and deactivating based on our construction sequences to simulate the same construction procedure in the software. And the next command is node and element. So this nodes entire icon, which is useful for the nodes. And second is these are the commands which is related to elements. Next is the change element parameters. This will help you to make a geometry, and you can change the thickness ID and element type. So this element type we can, as you're modeling as a one-dimensional element, the element can be by default as a general beam, or maybe afterwards, if suppose it's a cable straight bridge or suspension bridge, the cables are we have to model as either by truss element or cable element. For that, we have to change element parameters. Then accordingly, your input will be changed now. And then the mesh parameters is applicable for the plate elements. And next is the properties. So the properties wise, we have the material property, time dependent material property, plastic properties, and section properties. The first one, material properties, add. So this is the material database. So we have database for steel, concrete, and SRC. SRC is a steel reinforced concrete and user defined function. So steel, we can access the code and select the database. For concrete, in the second tab, that's for concrete, select the standard and select the grade of concrete, and you can see the property of the material it's displaying here. And if you want to modify anything with the same values, again just make a standard as a none, then these values are editable. If you want to make any dummy members by the grid lazy modeling, then you have to make as a none, and then this weight density we have to keep as 0. Okay, and second property is section property, add. This is the section database, and the first tab which we are seeing is the database user defined function. These are the standard shapes under this tab. That's a DB user type. If suppose, for example, I'm selecting a section, we have to select the standard, and we can see the database. So these are the databases inbuilt in the program. Select the cross section, then accordingly we are seeing the dimensions over here, and show calculation result. This will show the property of the section which will be calculated by the program. Again, the same tab, we have user defined also. For user defined, the dimensions are manual input. And second tab is value type sections. And here we have to give the dimensions as well as for the properties. This is a value type section. This is a completely user defined functions now. And SRC section, this is a steel reinforced concrete section. This is nothing but the composite members, either by steel embedded in concrete or concrete embedded in steel. These are the standard shapes under this category. Next is the combined section. These are the combined standard shapes. We can make this combination by database, select the standard, select any two sections. This is the joint arrangements. This is the dimensions individually. And again, the program will calculate the combined properties. Next type is PAC type. Only the database name is the PAC type. If you're making a RCC T-beam or I-girder, the cross-section is same unless we are defining the precise cable in the member. This will act as a normal RCC only. So here we have a box girder, I-girder, T-girder off section. And next is a taper section. Generally for our box girder type or I-girder grillage model, we are using the taper section near the support sections. So this tapering we can define here under the taper section, and this tapering can be a linear tapering, parabolic, and cubic. And next is the composite section. So we have the database for the steel box, steel eye, steel tube sections, and steel box and composite eye and TPSC. And next is a steel girder type. We have a steel girder box and eye. Two types are under this category. And the next tab is a thickness. Generally for plate modeling, we are defining the thickness over here. Okay, and this tab is a time-dependent material property. Whenever we are performing the construction stage analysis, we have to define the creep and shrinkage and compressive strength variations is based on the code as well as the grid. So when we select here, first I have to define what is the grade of concrete. Grade nothing. Grade means it's kind of a compressive strength values at 28 days. That value we have to give, and we have to select the creep and shrinkage variations along the standards. So we have IRC 112 limit state design is inbuilt in the program. We can select and give the relative parameters for creep and shrinkage calculations. And then the plastic material, apart from your RCC and PSC, we can define the plastic material like a Tresca model, von Mises, Mohr Coulomb, Regerberger, and masonry. So this is the property. It is completely editable, as well as the bed joint material, head joint material, and geometry. So based on this input, the program will calculate the actual property of the masonry. Fine. And next is boundary conditions. We have a defined supports. Then next is a spring support to simulate your soil parameters. Link, it's a connectivity member which is connecting for superstructure and substructure. Like for an example, it's a deck and pier cap, or pile cap and pile. So this is the link is a connecting members. And next is a releases. We have beam and release as well as plate and release. Next is the loads. We have this type of loads like static loads, temperature, moving load, dynamic loads, construction stage, heat of hydration, settlement, analysis. And then do the analysis, see the result. This is design features. On the left side is a tree menu. We are seeing 4 tabs over here. The first one is a table. So while we start doing the modeling in the graphic window, the entire information will be saved in the table automatically. And next tab is work. In CD it will be empty. When you start doing the things, the entire information about the inputs, it will be stored in the work tab. And next is a group. So this is a group what I explained earlier. The structure group, boundary group, load group, tendon group. These are the groups we are creating for the construction stage analysis purpose. So according to the construction sequences, we are activating and deactivating these groups with the standard loading information and the age of concrete. Next tab is a report. Finally, apart from the input file and output file, we can make our customized report in our own style. And bottom is the message window, command message and analysis message. And right side is a few viewing commands over there. And the right bottom is the unit system. We can set the unit system at any stage. So in CD I kept the unit as a kilonewton meter. So I'm creating the node first. Create the node. The first node creating at the origin point. I'm copying 5 times with a distance of 5 meters in x direction. As I said earlier, so this UCS is x is longitudinal, y is transverse, and z is vertical. And click apply. So 5 times we copied plus the source file. Totally we have 6 nodes over there. Now we are seeing 6 nodes on the screen. And this icon n dot, this will display the node number. Fine, once I close the things, I'll just save the file. Feedback ventures. First example. Fine, so we are seeing 6 nodes over here, and click close OK. Now you can see the work which is, it is showing that we have created 6 nodes over there. As I said, this information will be saved in a table format automatically. Go to table, structure table, node. We can see the coordinates in Excel, this table, and this table is compatible with Excel sheet. So if you have a coordinate system in the Excel sheet, you can directly copy paste also. Fine. Next is element creation. So create element. So these are the element type we have inbuilt in the program. Those are general beam element, truss, tension only, hook, cable element, compression only, plate, axometric element, and solid elements. So in general practice, we are using one-dimensional element, that is line modeling, and we can perform for a plate modeling also, as well as in solids. So this is the material thing which we have not defined it. First we will connect the things. This is node connectivity. Either I can just directly click on the nodes directly on the graphic window, or otherwise I can directly type the node number which I want to connect it. So I'm just entering now 2,6. Click apply. Automatically the element is joining over the nodes. And the intermediate points will be divided automatically because the intersect by nodes and elements will be selected automatically. So now we are seeing in the work, we have created 6 nodes and 5 beam elements, and the material and cross section we have to define it now. So go to properties, material, add. This is the material database. The first one is a concrete. Select the standard, this is IS. 35 grade, the same name will take place here. Or if you want to change the name of the material, you can change the things. I'm giving the name as deck. So this is the name we provided. Next is a section property. Add. So this is section database. Directly I'm creating a section in PSC type. PSC. Select the PSC N cell type. I'm giving the name as a box girder. Box girder 1. So number of cell is 2, and the same cross section selection I can select vertical web, slope web, and chamfer web. Accordingly, the B7, B8 will vary. So from the reference picture, I'm giving the dimensions that the H1, so depth is 2 meter, H2 is 0.3, H4 the cantilever tip is 0.2, and H4 bottom flange width, that's 0.3, H5 top flange thickness 0.3, and B1 total width is 12 meter, and B2 the cantilever distance is 2 meters, and B3 web thickness 0.3, B4 top haunch is 0.2, B5 bottom haunch is 0.2, and outer web thickness is 0.3. So if my dimensions are correct, then only this preview will happen. If the preview is not appearing over there, that there is an input, there is a mistake in the input. We have to check on that one. And this is the web thickness for shear and torsional calculation. If you have calculated manually, you can directly give the values. Otherwise, you can select automatic. The program will calculate automatically from the properties. And the offset to center top, so that your top surface will be uniform. Whatever the difference which we are providing in the depth in the different cross sections, that will be displayed at the bottom. And show calculation result. This is showing the property of the section. And automatically now we can see the web thickness for shear and torsional calculation is calculated by the program. And click OK and apply. Okay, now the input table is ready for the section ID 2. It's updated automatically. Now my cross section name is box girder 2. Here I can make my depth of the section will be 1.5. Remaining parameters are same, and click OK. So now we are seeing two cross sections which we have defined, that is a box girder 1, box girder 2. Now this is isometric view of the model. We are seeing box girder which contains the box girder 1 cross section. If we double click, it will highlight where these properties are assigned over there. And if in case if you want to modify the properties with the box girder 2 properties, it is very simple. You can just select the member by the selection option and click drag and drop anywhere in the graphic window, so that will be modified. So as you're seeing two different cross sections, one is a 2 meter depth, one is 1.5 meter. So the first one I have just applied the box cutter one. If I double click here from the works tree, the member will be highlighted where this property is assigned over there. And the box cutter one, the remaining cross sections, the remaining members contains the box cutter one property. Again, I'm assigning the same section property, that is a box cutter one, which is a 2 meter depth. So this icon next is a property material for section and completed. And next step is boundary conditions. The boundary condition is, first of all, we have to define the support conditions. As this kind of a box cutter, generally we have two bearings or three bearings over there, and to provide the three bearings, and we have to provide the three support conditions, and those supports to be connected with the structure. So as a structure we made as a one-dimensional model, that is the line model, which contains only one edges at each side. So that one node, the force which is coming to the member, that has to be transferred to the number of bearings. Okay, first of all we have to create the bearing nodes. I'm copying the node number 1 and 6, translating it. I'm copying the node with a distance of in y direction, that is 3.75, and vertical is -2 meter. So now we are seeing the first node is created at the bottom of the girder. Again selecting the same node number 1 and 6. This time my y coordinate is negative. So -3.75, vertical is -2 meter. So now we have two nodes at the bottom of the girder, that is our bearing locations. And again, these four nodes, again I'm copying one more time with a distance of 0, minus 0.25, that is your bearing pad height. So now we have to connect your structure to support. That is our boundary conditions. First of all, the first one we have to provide the rigid link, because the rigid link, if you want to transfer the load from one point to multiple nodes, that's a rigid link property. So we want to transfer the load from one to one point, that's vertically, that is the elastic link property. So now here I want to transfer the load from node number 1 to the top of the bearing. So I'm using the rigid link. There's no master node number is node number 1. And this is a rigid body because the complete concrete block. And the same way, while I'm creating the links on the left side, the same time I can do the link on the right side also by using the copy rigid link functionality. So this is the X. So my distance between the support is 25 meters. I'm keeping 25 meters. The master node number I entered directly on the table, and the slave nodes I have to select in the model and apply. And now we are seeing the rigid links in the model on both sides. So this is the rigid link which is created. And next is the elastic link, which is reflecting your bearing property. If you know the bearing stiffness directly, we can use a general type. Then we have to give your translation stiffness and rotational stiffness in this dialog box. Or if it doesn't know the bearing behavior or bearing type, we can select the rigid type. We can analyze and what is the reaction is coming at the support, so vertical reaction, horizontal reaction. So based on this reaction value, we have to design the bearings. After design the bearing, that value we have to use in the general type. So I'm using copy elastic link X direction with the 25 meter, and my node number is 9, 13 for my first elastic link. Apply, And next elastic link is 7,11. Apply. So the vertical link is created over there. Now you are seeing elastic link and rigid link. And then finally we have to provide the actual support conditions over here. And these support conditions we have to select manually which direction you are restricted, which direction you are allowing it. In this dialog box, if the checkbox is selected, it is fixed. If the checkbox is empty, that means released. So generally we have 6 degrees of freedom to define the support conditions, and now this program is having 7 degrees of freedom, that is a rotational against warping. That is your RW. So if you'd like to give a fully fixed supports, the D or all is the condition. Now this is the simply supported behavior. So we are considering the left side, all the translations are fixed. So I'm setting node number 11 and 13 as I fixed all the translations dx, dy, dz, and apply. And on the right side, it's a roller support. So I'm releasing the dx. So only dy and dz is applied over there. Now you are seeing the support conditions. And this support condition is showing in color pattern. So you're having 6 divisions, which is showing your rotational and translations. The same way, we can see the support by directions. This another way of displaying it. This triangle, which contains your 6-digit number, the first 3 digits are showing the translation conditions, and next 3 are showing the rotation conditions. And in this digit, if you're having the number 1, it's showing the fixity, and 0 is released 1. So it is showing this 0 and 1. Based on that, we can understand what type of support condition which we applied at the node. And next is the load. So first one, we are applying the static load conditions. That is the static loads. We have to define the static loads and then apply. So static load cases. This is self-weight. Load type we have to define. Dead load type, add, and cross barrier load. I'm giving the name as a CB. This is a dead load of component and attachments, because the cross barrier is the attachment along with the dead load. So this is the type, apply. And then WC, which is the wearing surface load. The load type is dead load of wearing surface and utilities. Add. So we have 3 load cases in static conditions. Live load we have to apply separately. Add. So now you are seeing your static load cases. Only the load cases we have defined. The loads are not applied yet. So we will be applying one by one. Now go to the static loads. Self-weight. So this is the load cases, self-weight, and this XYZ. So our UCS is X is longitudinal, Y is transverse, Z is vertical. So we have to give your factor, that is -1 on Z direction. Add. So the self-weight is applied now. Next is the cross barrier and bearing surfaces. So as this model is a line geometry model, so we have to apply as the element beam load type, that is a per meter length. So this is the beam load. First is the element beam load. This is the load case. It's a cross barrier load. This is CB. The cross barrier we have to apply at the edge of the slab, both the sides. So I'm using eccentricity, which is calculated from offset command, because we have used offset command while we're defining the cross section. And the eccentricity directions, as this is a straight member, your local axis and global axis are parallel. When the structure is coming to the arch, the curved structure, then we have to select your loading direction will be local y directions, because for every member's local y will be keep on varying it. So right now I'm selecting the global y for straight bridge. Our total width is 12 meters, so I'm giving 6 meters from the center line. And this is the loading direction, this is the direction, and W is the load value. I'm applying a 2.5 kilonewton per meter. As this is the line model, so I have to convert the load per meter length. Select the member, apply. And one more time I have to apply in opposite direction, that is my eccentricity is -6 with the same loading directions with the same load, that is a 2.5 kilonewton per meter. Apply. So the cross barrier load is applied over there. Now we are seeing the load values in the geometry, that is a 2.5 is the load value. In bracket you are seeing OE, that is your eccentricity distance. Next is the varying surfaces. Element beam load again. Load case is varying surface. So this varying surface I am applying directly on the element, so there is no eccentricity. Only the load value -2 kilonewton per meter. So I'm selecting the member, apply. Now we are seeing the varying surface which is applied on the line directly. So we have completed the static loads. We have 3 static loads, that is self-weight, cross barrier and varying surfaces, which we have completed now. Now we will apply the moving loads. Let's go to moving load. First step, we have to select the standard. Select India. Once we select the code, then the relative functionality will be appear next to that. So as this is a line geometry, so I am selecting the traffic line lanes. If your model is a plates, then we have to use for traffic surface lanes. So add, giving the name as a lane 1. This is the eccentricity. Eccentricity is nothing but the distance from the reference element to the CG of the vehicle. So generally this eccentricity which we are calculating from the curve distance as per the standard. So we have to calculate the curve distance to the vehicle, and here this eccentricity is referring from the element line to CG of the vehicle. So this is a 2 meter, for example, and the wheel spacing, this will update automatically based on what type of vehicle is coming. Accordingly that input will be takes place. And the span length we are entering for calculation of impact factor. Our distance is 25 meter. Or if you have calculated by yourself for the impact factor, then we can directly select the impact factor. I can type the values. And the vehicle load distribution, this is the single line geometry, so it is within the lane element. Whenever you are modeling the grillage model, that time the load distribution for live load between the two main girders is based on the cross beams. So that time we have to select load distribution through cross beams. So moving load directions is both sides, forward and backward, and select by 2 points. So this is my starting point, this is my end points, and apply. And then next is a lane 2. Remove the existing coordinates. Select one more time the 2 points, starting point, this is the end point, apply. So we have created 2 lanes over there. You can see the 2 lanes in the geometry. I'm doing it one more time. We have to select the 2 points, that is from starting point from here to here. So we have 2 lanes now. Our next step is we have to select the vehicles. And this vehicle definition, we have a standard vehicle and user defined vehicle. In standard vehicle, you are seeing that IRC vehicle because at the beginning time we have selected the code is Indian standard. And these are the standard vehicle as per the standard. We are selecting class A, first load type, added, and second load 70R vehicle, apply. So we have defined two standard vehicles. Fine. So next is the moving load cases. Add. So this is a moving load case. I'm giving the name as the MVC, moving load combinations. We have two options, whether we can perform the auto live load combinations or otherwise we can manually do the combinations. I will show both the options. This auto live load combinations, we are defining that number of design lane is 2, add, and we are defining what is the loads. This is both the loads class A and 70R. It's loaded with both the lanes. Select and apply. So this is the auto live load control. Next is manually remove the tick mark from auto live load, add, and here we have to select what is the vehicle. One by one we have to select. So class A loaded with lane 1 and minimum number of loaded lane is 1, maximum is 1. And second lane specifically made for 70R, then select the lane is lane 2, add, and OK. This is the manual combinations. So according to your interest, you can make your auto live load combinations as well as the user defined combinations. So I'm considering auto live load combinations for this example. Select and OK. So the live load is completed. So I will just show what are the steps we have created. We created the geometry and we applied the M35 grade of concrete for deck, and we have created two cross sections. One is a 2 meter depth and 1.5 meter depth. The first one is a 2 meter depth, which is we have applied throughout the section, and we have 4 support conditions, which is a simple support condition, which is reflecting your pin support at the left side and roller support at the right side. And we have connected by elastic link and rigid link, and we have applied the self weight and crash barrier load. We have applied on both the edge of the slab with a intensity of 6 meters from the reference element, and the wearing surface we applied at the on the element directly with the intensity of 2 kilonewton per meter. And then for moving load, we are performing as per the Indian standard. We have defined 2 lanes and 2 vehicles we have selected, class C and 70R, and we made the auto live load combinations for moving load cases. So this is completed, and go to the analysis, perform analysis. So now you can see the analysis is completed successfully. Now we can extract the results. So go to the result. First step is load combinations, concrete design, auto generation. Select the standard, this IS6 LSD, click OK. So these are the 3 combinations which we created by automatically. If you are interested to make your own combinations, you can give the name here. Give the load combination name. These are the load cases. We can add and define the factors on the right side. Now we are extracting the result one by one. This is the result tab. First one is the reactions. Here we can see the individual static loads and load combinations and moving loads. So this is the value display. This is the legend. Apply. So we are seeing the reaction forces due to self-weight. Next is deformations, displacement contour. Select the load case or load combinations. With the deformed position, that now we are seeing the value of deflection and legend with a deformed position. Next is forces. As this is a beam element or one-dimensional element, we have to extract the result by beam diagrams. Select the load cases. As per this component, My is the component for bending moment, Fz for shear force, Mx for torsion. Now I am showing the result for moment My. This is the bending moment diagram, you are seeing it. And Fz I'm selecting right now. This is my shear force. And then Mx. This is for torsion. And next result is stresses. We have to select beam stresses. And the component test which is showing your axial stress, bending stress, and shear stress. And there's the last component is combined stress. We can see the combined stress for the 4 locations, that is your 1 and 2, the reference picture which is displaying the 1 and 2 are the top stress, 3 and 4 are the bottom stress. This is the combined stress diagram for the maximum of all the component. This is the result. And these are the results which we are seeing in the color contours, as well as we can extract the result in the form of tables. Go to result table, beam diagram, stresses. This is the output in the form of tables. We can select the load cases or load combinations and click OK. Now we are seeing the result, detailed result in the form of tables. So this is the axial stress. These are the shear stress in Y and Z direction, and bending stress Y and Z direction, positive, negative. This is a combined stress for top stress and bottom stress. Fine. So as I said, the last tab is a report generation. So whenever we would like to take the result, we have to make our own customized report. This is the reaction diagram which we saw. Right click, go to dynamic report image, save the things, and deformations, displacement contour with a deform location. This is a picture if you want to place in your reports. Right click, dynamic report image, add it. And forces, beam diagram, My is the bending moment. This is the moment diagram. Right click, dynamic report image, give the name for that, click OK. And stresses, beam stresses, add dynamic report image, click OK. Okay. Similarly, I will take one result for the table format also. Right click, dynamic report table. I can select what are the columns I want to include in my table. I can select, remaining I can remove it. Now you might have a question over there. I have just saved all the tables and pictures. Where it is saving then? So you can see this last tab, that is the report generation. Here you can see the pictures and tables. Now I will explain how to generate this report generation. Go to Tools, Dynamic Report Generator, New Document, click OK. Now this is the Word file which is opening in Midas GUI. So this is a normal Word file which is opening in this screen. As we have saved this results, we can drag and drop in the Word file. So this will make our customized report format as per our convenient. This was table. And the cross-section summary, it will create automatically what are the cross-section which we have defined for this project. So that will automatically save in the section property that you can just drag and drop. You can see the picture as well as for the property of the section. Once this is done, just save this file. FP. Give the name for that. So this is done. Now I will just close the report, minimize the screen. I can see the folder.
Hi, Mr. Kevin. This is Tanmay from Midas.
This is the folder. This is the report.
I'm good. How are you?
Now it is showing in the normal Word file. So the further customization, you can do it for yourself. You can type the project name or company name, company logo, everything you can do as usual in Word file.
Okay.
And another facility you have in the report customization, once the report is generated and further you are doing any modification in the model, again you can open the dynamic report generator, open the old document, and the old document will be automatically updated based on the changes which we are doing in the model file. So this is the way we can make our customized report, as well as we can do the modification after report generation also.
Okay. Have a good day, sir.
Fine. So this is the first session to explain the basic model that I have selected for the simply supported single span box girder bridge. We have considered for self-weight, crash barrier, bearing surface, and moving loads. Fine. Do you have any questions? Yes, please. Hello.
Yes, yes.
Yes, sir. Please tell me, do you have any questions?
That's right now.